In progress.
Okay, yeah. Let's start. Neil, could you log into the Zoom? Last time we finished section 5.1 to 5.4. So how about we keep going, finish the left sections in chapter 5 before we go to homework chapter 5 test. So now let's go here. Equation and inequality with log and exponent. Okay. Yeah, first example. First one. Let's say consider following two equations. So first you can take this, even give it a name, for example, m. How about that? So we have m squared equal to 2m, right? Then you can find the value of m equal to 0 or m equal to 2, right? That means that ln of x equal to 0 or ln of x equal to 2, right? Then you keep going to say if there is certainty. Then this should be 1. So from this we get x equal to 1. Why? Because is 0's power equal to 1, right? Then here x should equal to e squared. Yeah, because e squared equal to e squared. So x equal to 2. Yeah, anyway, so this is a basic concept about logarithm equation. For this, so the idea is both sides take logarithm. Here use a natural logarithm, right? Then get this. Part A. So they do a replacement, right? Let this represented by t. So ln of t equal to 2. So t equal to this. Then keep going, get this. Yeah, anyway. Part B. Yeah, think about part B. How to solve it. Part
X equals to -2.
Say it again.
X equals to -2.
-2?
Yeah, because you have to.
You mean ln x is -2? Do you mean this? You mean x equal to -2?
Well, I think it. Root.
How do you think, Neil?
Yeah. Would it be like it's an exponent like that, or would it be on like right next to it? It should be like there's no real solution.
Yeah, because we know y equal to e of x is always greater than 0. So there is no chance to be -2, right? Yeah, that means that we should pay much attention to its like domain. What is the domain? What is the range, right? In order to guarantee it's defined. Okay, then let's keep doing this. For this,
It's 2.
oh, you mean it's equal to 2?
Yeah, x equals
X equal to 2? Yeah. We have this kind of formula, right? B ln B of x just equal to x, right? Okay, yeah, yeah, we have this kind of formula. Base of 10. Yeah, then for a, suppose x squared minus 2 should equal to 10 cube, right? Then keep going to solve it. This any different? Oh, here is 2x. So this again we have. Then suppose we'll get two value of x can have two different. Suppose x can have two solutions, right? Maybe one is positive, one is negative. Anyway, we check to make sure this as the input should greater than 0, right? So let's say if finally there are two solutions for part B. Go to verify both are solutions. Equation in quadratic form that involve axes. Find the exact value of this intercept and also a calculator. Find its x-intercept. Then let y equal to 0. Solve this, right? So first take 3x power as the variable. Yeah, use t represent it. Then find t. Find t. But t cannot be negative, right? Let me see. Yeah, this is impossible. So disregard. So for this, any idea?
You combine them.
Oh yeah.
Combine them and then you do that thing where you like you square.
Yeah, I think exactly. So for next problem, we may need new answer first. Yeah, combine first, then per its definition, get this. Yeah, normally when you get an answer, you'd better check to make sure it's defined, right? So let's say, but this suppose need disregard, right? Because make this undefined. This looks okay. So finally, we just have true solution x equal to 1. Property summary. Okay, let's see here. Positive constant greater than 1. Says anyway, if p less than q, then b p's power less than. Yeah, if it's greater than 1, then suppose it's equation for the exponential function, right? Then if p is smaller than p's power also smaller than q's power, right? Yeah, anyways, just because the exponential function is like a one-to-one equation, or if b greater than 1, it's equation. Then similar thing for logarithm. It's also like a one-to-one equation function. So if p less than q, we have this. But the case is different for if b is between 0 and 1. But now we talk about the inequality. Let's say we'll watch this together. First, simplify it. We get this. Here base is 0.4, means it's less than 1, right? Using property 2a above. It's for b greater than 1. Then how about b? When we get this? Oh, okay. They take natural logarithm. The base e is greater than 1. That's the reason we don't need the reverse, right? But maybe we can use another way to think about it. For example, we draw the photo of y equal to 0.4x, right? Then suppose it's like this. It's decreasing, right? So, for example, if we suppose 5 over 2 is here, 5 over 2. We have 0.4x less than this. Then suppose it means from here to here, right? That means we should have x greater than a place, right? And what's this place? Suppose it's a value 0.4. I just call it c equal to 5 over 2, right? Yeah, of course we can get c equal to base as this, but here is 2.5. Yeah, let's use calculator to find this. Can you do? The base is 0.4. The input is 2.5. Yeah. Let me see.
Wait, C is 2.5.
Yeah, here is 2.5.
I got this. I'm not too sure about this one.
You already
Could I add something else? Oh, wait.
no.
Yeah.
We do here. We want to find a number C. Let 0.4 C's power go to 2.5.
Yeah, okay.
Then you have to use logarithm, right? But I still not find the base. Let me see. Oh, yeah, we have. You see, log y. Y is base. Means y can take any base. So when we do this, we have 2.5 first. Then push this. Then type in 0.4. Oh, -1. Not possible. Let me try again. Log y 2.5. Take this.
The only log I have is just log. That's
0.4. Why is -1? Oh, maybe. Yeah, this is -1. Can you imagine? This equal to -1. Because 2.5 just equal to 0.4 -1. Yeah. Mm. Yeah, that means that I use some method different to what show here, right? That just per exponential function. Anyway, let's check if we get the same answer. Keep going. What's this? -1. We found that x greater than this. Oh, hold. Here is 3/2, but I use 5/2. What happened?
Because they subtract 1.
Let me see. Oh, okay. So I use something different, right? Let me rec. Yeah, we do it base this. So here should use 3. Then here is 1.5. So it's not -1. Okay. 1.5. Then take this, then 0.4. Yeah, get a negative number. Yeah, it's like this. Negative 0.44. About. Yeah. Okay, then let's go next. Okay, we'll just talk about the part B. Now I'll ask Neil, do you have any idea to do this?
You can like,
Yeah, could you write what's next step you can get?
can you do? But I'm not, oh wait. Okay, I'm really bad with stuff.
Oh.
Can you do something like this?
Ray, how do you think? Do you think this?
You first you
This equal to this? Suppose no, right? Only when it's multiplied. For example, ln 2 times 3x then you get ln2 plus ln3x.
Okay.
So we don't have this kind of formula. Okay, let me talk about it. So first, you think about 1 means what? Ln just e, right? Then here the base is e, it's greater than 1. So we have 2 minus 3x less than or equal to 1. Right? Yeah, the reason is for the logarithm. You say it's increasing. So means the smaller the if these two points compare, here has a small function value, so here has large function value, then this x is also larger than x here, right? Anyway, so we have this. Oh, hold on, let me say ln. Yeah, not 1. Suppose here is e. Yeah. Then 3x greater than 2 minus ex greater than 2 minus e over 3, right? Let me see. But do you think this is the correct answer or solution?
Maybe.
Yeah, I suppose we need one more condition. This should what? To make it defined.
Should be positive.
Should positive. That means that 2 minus 3x, then 3x less than 2x less than 2 over 3, right? So these two conditions should satisfy both. This is positive or negative?
This is negative.
Negative, right? So that means that x greater than negative number but less than 2 over 3. Then it's the solution, right? Okay, so let's see. Yeah, so always remember the domain. Cool. Okay, yeah, do I have the, oh yeah, here is greater than or equal to, right? Yeah. Then let's go next. Into account and determine the solution. Yeah, how about this time we think about part B. Neil, do you have idea?
Part B.
What is your first step
I guess
to
for this
like
one,
simplify it or
this one you can do like multiply, right?
multiply? Yeah, then what you can get?
Could you get like
Could you write on screen? Yeah, let me say. Okay,
and then you could do
then again the base is greater than 10, right? Greater than 1. So we have x squared minus 2x less than or equal to 24. You solve it. Then you need to make sure, yeah, that means we have one other condition, x greater than 0. And here, x greater than 2, right? So these three inequality should all satisfy. Okay, so let's go to see what the textbook say. Yeah, normally get the domain first. Then oh, they make drawing. Anyway, it's fine. We require what? I suppose it's not so hard to solve this, right? -4. Take into account the domain, right? Anyway, finally, we should get x greater than 2, but less than or equal to 6. Okay, so let's see how many exercise here. C, B. So in part A, let's take one. Neil, you take one. Just here, from 45 to 70. You take one. We'll do it together.
53.
53. Okay, so we'll give an exact answer as well. Decimal approach. Fine, if we can get the exact answer by calculator, of course, we can get the approximation, right? Anyway, let's do this. How about you do this, Neil? Then I give you another one. 54. Okay, now you can start. I'll give you whiteboard. You can just write on screen. Oh. So inequality is kind of harder than equation, right? Use calculator. Ray, are you done?
Yeah.
Use calculator to get it. What's it? Yeah, Neo, you can also go to get it.
Would it be like that though?
Mm.
Surround the edges.
Okay. Yeah, talk about here. This number is correct, but what I get is should less than in order to greater than. But let's check. If you mean it's greater than, then suppose 0 works, right? So let's take 0. Then zero's power is just 1. 1 minus 1 anyway means the left side is 0, right? 0 less than this is false, right? Then suppose at one place you should reverse the inequality, but you didn't do it, right? Yeah, anyway, what I get is less than or equal to. Yeah, Neo get. Yeah, okay, this is correct as what I get. So, right, we get same thing. Okay, let's. Yeah. Then part B. We want something. Okay, 72 and 90. Okay, this for Neo, this for Ray. Let's try. Excuse. Oh, 90, you need to go to, let me see, solve the inequality. You should find that the solution set. From example 2. So 90 is not good to do, right? Because we need to go to see example 9, part B. Can we quickly go to there to have a look? Oh, oh. Let me remove all this first. Go to example 9B. 9B is like this, right? Yeah, let me write here for you. Oh, no. Okay. Yeah, how about this? Neil do 90, 69, Ray do 70. Yeah, you forget here. Ray, you just do 70. Yeah, Ray, try to show some steps on the screen. First, combine them,
Yeah, I see.
right? Then 0 you can take as a log base 2 of someone. Then as here base is greater than 1, right? Then either the left side one greater than that or less than. Uh, then you can remove the log. Just go to some regular rational inequality. have done. So we have log. Anyway, 0 you just take as log base 10 of 1, right? Then we have x squared minus 6x minus 6 greater than 1. Well, we just rewrite it as minus 7. Then we have x minus 7x plus 1 greater than 0. Yeah, here is greater than 0. Then suppose what we can get. X less than -1 or x greater than 7. You say different to this, right?
Mhm.
But is this the solution? Maybe, yeah, anyway. When this means this is true, then of course x squared minus 6x minus 6 should greater than 1. That means it greater than 0, right? Yeah, then suppose this is okay. This is just a solution. But different to what you get, right? Not here. Do you get any idea?
Not really. I just like the odds.
Yeah, and it's not so hard. So could you combine it first? Means even you cannot completely done this problem, you can do part of them to get part score, right?
Yeah.
Yeah, if the full score is 10 points, you can go to get like 3, 4, or 5 points by write something. Really, you can also think how to solve problem 69. Mm. Mm. Uh, hold, not exactly. Yes, less than 0. Log base 2 of this. Let me circle this. Less than 0. But as we already write, what means 0? 0 just means log base 2. Yeah, in this problem is base 2 of 1, right? Then we have this less than 1. Right?
Yeah.
Now it's nothing to do with logarithm. So you don't need to hate it. How to solve this inequality?
You just try to find like something that's like smaller than 1.
Okay, so let's take a screenshot for this first. We'll just keep this. Then solve it together. Uh-oh. Yeah, we just keep this. Think about how to solve it. Yeah, we don't need to say this anymore. Yeah, think about how to solve this. Then finally we can go to check answer. This is 69. Suppose there is a provided answer, right? Yeah, please do it. Neil, can you try?
Yeah.
Oh, even I would appreciate it if you can write on screen.
Yeah, I'm just trying something.
How about I divide the screen? Ray, you can still do it in right side. Show some steps.
Okay, so it's just. Could it be like this?
X less than 3. How you know?
Oh, because I plugged in 3 and like that was 1, so it can't be 2. And like everything below 3.
Maybe not so
Oh,
simple.
except like negative.
So Ray, what do you mean? You get X less than 3? X less than -2?
Negative 3.
Yeah, if it's 2 inequality, you should mention it's and or, right?
Just
Yeah. Anyway, get it completely done instead of just guess part of the solution.
could it be like, can you do this?
Yeah, you can, but how you get this? My question is,
I just,
you just by guess?
yeah, I guess I check.
And Ray, how you get this?
Right, solve this.
Mm. Okay, I'll give you guys several more minutes. I also think about it. I still not get the answer. Mm, mm, mm. Yeah, so this is correct. Okay, let's do it together. I'll wait. Ray provide his final answer.
Oh,
Are you still working on?
yeah,
Mm. Yeah, we solve this.
Great.
Okay, I get my answer. I'm waiting for you guys.
Um,
All of this. Hmm. Ray, are you done? Means you just think answer is this, right? Okay, now let's do it together. Of course, this we can let it go to 2 of x plus 3, right? Mm. So in order to solve this, we would like clear fraction. But then we need to know if x plus 3 is positive or negative, right? If positive, we don't need to reverse the inequality. If negative, we need to reverse, right? Yeah, but fortunately, we actually know this should greater than 0, right? That means that from its definition, we should have x greater than 0, x plus 1 greater than 0, and 2 of x plus 3 greater than 0, right? So that being said, we know this is greater than 0. Then we can both sides multiply it. Mm. But we make sure with the domain. This means x greater than 0, x greater than negative 1, x greater than negative 3. So together, these three conditions should satisfy at the same time. So we have to have x greater than 0, right? Then, of course, we guarantee this is positive. So both sides multiply this. We have x squared plus x less than 2x plus 6. Then x squared minus x minus 6 less than 0. Factorize x minus 3, x plus 2 less than 0. Then we know this the solution for this is negative 2 to 3. But combine this, we have x greater than 0 but less than 3. This is the final solution, right? Okay, so let's go to check answer. 0 to 3. What's this section? 5.5. Hmm. Oh, too much. 5.5, almost. 69. Yeah, you see? 0 to 3. Right? Okay, let's take a break. Now part C, let's take one. Ray, which one you want?
uh, which one is the easiest?
Never mind. Just take one. Oh, yeah, you just take one. Never mind which one is. Maybe we can take odd number. because there is answer, right?
One choose 93.
93. Okay, let's see. Who's losing? Huh. Already told you there are two cerners. By the way, do you think 1 makes sense? X just equal to 1. Yeah, we found one. We found one solution. Yeah. Then keep brainstorm.
2.
2. Then we're done.
Would it be
If
2?
2 is true, maybe this time maybe not so lucky, but we can check.
Yes, it's
2. 2 of 2 just means 4. Here equal to, yeah, we're done. But if there is no hint, how we know there are just two solutions? Now let's think the matter. Why do you think an x can be negative?
I mean, it just be complicated.
If, for example, negative 1 of negative 1, what's negative 1? This equal to what?
That would be like
Negative 1 of negative 1 means negative, so just negative 1. Then, yeah, anyway, it's equal to negative 1, right? Then how about this? Negative 1 of negative 1. Then take negative 1. Again, this is negative 1. Yeah, suppose it's equal to, right? Maybe here has condition means x is positive. Is there this kind of condition? Then we get more than two solutions. Right? Then again we can check negative 2. So here go to negative 2, right? Keep this. Negative 2 of negative 2. So it means negative 2 square over 1. Right? This is, so just means, oh, negative 2 fourth power. Fourth root. So what's this?
um what's root 2 times size?
Undefined, right?
Yeah.
Because you cannot find a number whose fourth power equal to negative. Impossible. Yeah, anyway, we already get 3. If we take x just greater than 0, is there any way we can solve it? Let's try. Mm. Oh, first this should go to X, this is exponent, right? But for here, it actually means x square, right? Mm. Then suppose we have x equal to x square. Then what's next? So at least we can get x equal to 2, right? Mm. Yeah, we can get x equal to 2. But how we know x can be 1?
You just guess.
I mean, in this process, why we don't find the x can be equal to 1? If x is 1. Yeah, okay, we can just say, oh, it's obvious x can be 1, right? Okay, let's go to check answer for 93. Yeah, just 1 and 2. They don't consider negative surness, right? You see, in our exponential function, we require the base greater than 0. Mm. Okay. Okay, now let's go to next section, 5.6. Compound interest. So what is another type of interest compared to here compound?
Contact.
Compound actually means kind of complex. I think another one is simple interest. You learned during like uh, elementary school or middle school, right? Simple interest means each year you just get same interest. For example, for a case, you save in $1,000. The interest rate is 5%. Then after 3 years, how many interest you can get?
15%.
You just mean 1,000 times 0.05 times 3, right?
Mm.
Yeah, if so, it's called simple interest. Uh, but it's not the truth. So practically, actually, after first year, your money go to 1050, right?
Mhm.
Then in second year, you go to time 1.05. Yeah, how you get this? Just use this time 10.5, 1.05, right? So then that means that actually this $50 from the first year's interest also make interest in second year, in third year. That's the truth. Mm. So anyway, the true case actually go to just the beginning money time. Oh, just now is 1.05, right? So yeah, starting from here, after 1 year, it's go to you time this. Then this is your starting money at the beginning of second year. Then again, time this for second year, then for third year, and keep going. Then finally you have this time 1.05 if it's n year. Mm. Yeah, so now let's say this example. After first year, the money go here. Then after second year, go to this square. Then keep going. Yeah, this is get from simple interest rate. This get from compound interest. Yeah, so compound means the interest generated also make interest, right? Yeah, anyway, we call this compound interest. Yeah, so here is the formula. R is the annual rate. T means how many years. Then you can use it to company, calculate the compounded interest. It's what happened in the real case. For example, you really deposit money to bank. Mm. Yeah, then just use formula. Yeah, here actually means double means your money go totally go to 4,000, right? Then we want to know how many year it need to achieve this. Mm. That means it's like this time we need to know the equivalent, right? Yeah, so that's the reason we need the logarithm. Anyway, so this is even more complicated. Means compound n times per year. Yeah, normally, for example, for the bank, they just mention the annual interest rate, right? But sometimes, for example, you just deposit money, then you take it back after like 3 months, or even just after 1 month. Then how we can calculate it, right? So this is the case compound n times per year. So anyways, here is the formula. R divided into n parts, so R over n. T years, but each year you compound n times. So totally you compound n times t times, right? Yeah, okay, just read here. Make sure you understand it. Mm. Total number of compound periods. Okay, are you with this formula now? Mm. Yeah, now let's do one. You already say the formula. Can you, maybe we can just compound the quarter. Yeah, we just do part B. Let's see what kind of answer you'll get. Formula is here. Practice. Leo, could you have a try? Here you get
Memorize the formula, but I just forgot like where the numbers go in
oh, okay. So let's go through it. Which one you are not sure?
the 10%. Like where does the 10% go? Is that the R?
Oh, yeah, 10% means annual interest. This word.
So would it be like 1,000 goes into the P?
Yeah, P means principal money.
1 plus 0.1 over 4
Yeah.
to the power of n.
N is 4. Yeah. And T is if here means end of 1 year. So T is just 1.
Okay.
Yeah, Ray, if you get answer, you can write on screen.
I got 1. I got
For part B, right?
I think.
Ray, do you get some answer? Yeah, by the way, think about if compound once each year compared to compound quarterly, which case net you get more money? If it's you who saved this $1,000 to bank, which case you get more money?
B?
Yeah. Why?
Because you get 4 times.
Yeah, I suppose when you have a compound, you get your interest, right? Then this interest immediately go to generate interest in next period. But if you just compound one, you have to like wait after 1 year, you obtain your interest. This will only get new interest the coming year or the coming period.
And then n equals 4 means you'll get like 4 times a year.
Yeah.
So what if you did like 36 or something?
Oh.
I think like the income will like get infinitely close to natural number. I think that's
So this is by Ray.
Yeah, we pretty much got the same.
Oh, you get the same thing. Okay. Anyway, let's see. Yeah, so we suppose in part B you get more money, right? Let's see. Yeah, need a bit of more. Okay.
But I think like the growth would get like infinitely close to natural. That's the natural number.
Yeah, here has more concept. We will not go through them. So so in the coming contents, we will think about if the n is as many as possible, what happens, right?
Yeah, I guess it's close to.
Yeah. Yeah, just now we talk about 1 year. If it's 4, means you compound quarterly. If divided by 365, means you compound each day. Then you can keep going like this, each minute, each second, and even more times in 1 year, right? So think about this is actually the natural case. Means, for example, for your air, it's always growth. even it's you divide 1 second into 1 minute apart, right? So for very short moment, your air grows and go longer a little bit, right? Mm. So again, this go back to the case. We have an idea called E, right? Yeah, again, review this. Let n approach to infinity as bigger as possible. Then we call the result is E. If so, we will get this. Yeah, they didn't mention why we get this, right? Uh, let's say let's go back to this formula. Go this formula. Yeah, we just want let n go to as larger as possible, right? So you just do this. For example, p still p 1 plus. Here we want 1, so we use n divided by r. Okay, this actually is this, right? Correct. Then here, as here has n divided by r, we want n divided by r. Then we have to have a RT here, correct?
Yep.
Yeah, now let's think about this. Yeah, if you give n over r a name, just call it this uppercase n. Then we have this just go to 1 plus 1 over n and n, right? Yeah, remember we just wanna let n if n approach to infinity, then we call this is E, right? Mm. So now you can say R is some constant, right? So as n, this n go as larger as enough. So this also go as larger as enough, means approach to infinity. So actually we just call this is E. This is E. Then we get the formula P E R T. That's how we get it. Mm. Yeah, we call this compound continuous. Mm. It's what happens in natural case. Anyway, we get this. So it's suddenly from some number n go to E. Right. Now let's say a principle of this. Connects in your 7.5% compound. Yeah, you say we call this compound. Oh, come on. Compound continuous. Assuming no subject withdraw audio. When will the balance reach this? Okay, now can you use this formula to calculate it? Yeah, make sure you're familiar with each letter represent what. and you practice on it, then you'll know more. Get strong idea.
Compound approaches.
Show your answer.
It will be around one.
Around how many year?
Uh, around one, but it's not
1 year?
around one. Not specifically one.
You mean close to 1 year?
Close to.
No, but I don't think you can get so much interest.
What is
If 1 year, this is just 0.05.
what is it after?
Ask means after how many year your balance go to, your total means including your principal money and the interest. Your total go to 2,400.
Oh, okay, I see where.
Oh,
Okay, it's 8 years.
close to 8 year, right? Actually 8.11. Okay, let's say, yeah, just use this formula. Yeah, it's here. Then 2,400 divide 1,600 go to 1.5, right? Then take logarithm. Anyway, then it's 8.1 year. Compare continuous to annual compound. Yeah, you go to read this. Then again, suppose which one you get more money.
Exactly.
One case is compound continuously. Another is compound annually. Which one let you get more money? You say, count one. Another count two.
It's continuous.
Yeah, continuous. Means for each moment, they give you the interest.
Yes, you can.
Then you let it have derivative interest in next period, all the coming period. Yeah, but let's say something. Yeah. What's this? Yeah, they get more and more. the difference is bigger and bigger, right? Okay, we'll pass this. Double time. Yeah, here just give you a formula when the one will be double. But it's easy you get this yourself. Okay, let's just pass it. Oh, this has a nice problem. Let's just pick one.
Because they're all workable.
How about 25? Let's say. You say one. Why some gun impose and why the invest $1,000 at after 300 years, how much would be in their account? Okay, anyway.
More likely that is that the bank would just go bankrupt.
Yeah.
That's something more like.
You just want to know this from here. Right. Then just calculate it. Yeah, Neil, make sure you have a try.
Yeah, I'm doing it right now. But this
Still remember the formula?
Yeah, I remember the formula, but I don't get it.
You get one time.
Let's say, let me write it.
There's like 1,000.
So A means amount, right? Means your final amount. P principal money. E. R means annual interest rate. T means how many years, right? Then yeah, we just use it. P is 1,000. E is E. R here is 0.08. 3 years. Oh, sorry, 300 years. Right?
Yeah, you get.
So would it be like
choose the
this 1,000 e to the 0.08 times?
Means very, very big, right?
Yeah.
A very, very big number. But
Okay.
can we still get a value?
I can even type E on my calculator, so that's nice.
E 24. 24 E then time 1,000. Oh, so it's oh, 4,000.
Oh, I got a pretty big number.
But yeah, this is a pretty big number.
Got this.
Yeah, yeah.
To the
so
10 to the 13.
Yeah, that's but I see no bank would be able to survive that much. Or to say, you know what? Or to say,
oh yeah, I forget. I forget something. I still need to have 129 of 1,000. Anyway, it's a Garrett number.
Imagine if I saw it wrong.
Okay, now let's go to last section. Exponential growth and decay. Yeah, actually, we already talked about the exponential growth just now, right?
let's skip to decay.
It's horrible.
Would decay just be like negative? There's like decay.
Yeah, so it means growth. But for decay normally means the base is between 0 and 1. For example, if it's half, means this is a watermelon. First, you let this go, then you half it, let this go. You half it, let this go. You half it, let this go. Right?
Yeah.
Like this. So it means decay. Exponential decay. Oh. Yeah, you just read the exponential decay to make sure you are also familiar with this. A, E, E, X. A is positive and B is negative. So, between growth and decay, suppose the breakpoint is base is 1. If it's 1, it's just stable, not growth, not decay. But if the base is greater than 1, for example, 1.01 x, then this will growth. But if it's just 99, then this will decay. Right? Then let's talk if 1, it means E0, right? Then if it's greater than 1, it means yeah, let me just call this, no, not E. Yeah, suppose the base is ER. This R should greater than 1, right? Then similar thing if it's within, if the base is within this, means the base is ER, but this R should less than 0. Anyway, so the breakpoint is depend on the exponent of E is positive or negative. Yeah, but when we talk about the time t is always positive. So it's depend on the coefficient multiplied with t. Yeah, another thing is, for example, the base 2x, right? You can always translate it to e a number of x. Then even we'll let r and x time together, right? So what should be this r? If yeah, if this is the equation, what should be r?
It's 2.
No, it's not 2. If it's 2, here is e square.
Oh,
E square, of course, greater than 2.
Natural log.
Yeah, so can you find this r?
Yeah, it's natural log.
What do you mean?
Like natural log 2.
You should have an exact value for r. Right? Means r is just a number.
But that is a number.
Which let e r's power equal to 2.
It equals to 0.693147181.
Oh,
I did the calculation in my head.
Okay. Yeah, so anyway, you can find the r, right?
Sure, nothing here.
Okay. Modeling spectral growth. Uh, 2 hours later, the size of one is found to be this. Assume that the population size grows exponentially. Which one we want to find? A, B, C. Determine the growth constant K. So it means just use this kind of formula, right? Then you just go to n of t equal to n0 means initial. E still E. K we still not know. T is how many hour? 2 hour. Right? Then we can go to find the K. Yeah, let's check. By the way, we have to, yeah, my point is how we know we should use time based on hour, a minute, a second, right? That's my point. Exponential. Yeah, when we get K, looks like K here just mentioned it's a constant, right? Yeah. So it looks like if we talk about hour, then this means the growth rate per hour. Of course, you can go to do it per second. Then what you get is banana per second. Uh, yeah, then use the obtained formula to calculate t equal to 1.5. T equal to, then we get this. Remember, start as 1,200. Now it's this. After 2 hours, it's 1440. Right. So this is between. Then part C go to find the time t. Yeah. Anyway, average related rate of change, percent increase. Very good. So it means there is a fixed relative growth rate, right? Like the common ratio in geometric sequence, right? Okay. With world population growth. With a relative growth rate of about, let's say, This is 0.7% per year. Use this time 25. Okay, we'll pass here more on word problem. Doubling time formula. K is the growth constant. Yeah, it's like the growth rate, right? Similar as growth rate. We'll pass it. Definition half time. Yeah, this we should know. Half time, especially for radioactive substance, right? Means after a period, the content just go to half. This is the case for decay. Just now we talk about growth, like go to double. Now we talk about go to half. 8 days, suppose that. So at the beginning there is 2 gram. After 80 days, just has 1 gram. After another 8 days, go to half of this, half, right? So we call this kind of period is half life. Determine n of day 8 equal to n0 e k 8. But we know as 8 days is half life, means the content go to half, right? Then we have this. From it, we can get k. Then is there like general formula? Let's say property summary. Again, we call this k is what? Dk constant. Property. Oh. K equal to this divided by half life. Okay, yeah, just make sure to use the formula and use it correctly. K is something we just call is constant. Either like growth constant or decay constant. Then maybe we don't have time. We try to practice one. Let's say how many problem here. And looks like not a word problem, right?
They're all work.
Yeah. Let's find one. Not too time consuming.
Let's find the E2.
A basic one.
The
How-
answer key is pretty easy.
How about for this we need
Just do fundamental.
we need to use formula here. No, let's forget this. Let's go to find. Yeah, how about 26? Oh, no. 27. I said certain trace to measure the rate of flow in an oh, oh, the half-life is 14.9. Suppose that a hospital bio how much of the sample will remain after 40? How long will it be until only one? So can you make it?
Like 3, I guess.
Not guess, but by your calculation, what's the answer you get? Again, Leo left side, Ray right side. Yeah, write your answer on the screen. Yeah, I suppose it's A equal to P. P is 40. Yeah, find the answer, then write it on screen. Get the answer? Yeah, you can just use this. Let me write it. A means the amount left, right? Equal to P. P like the starting value. Then half of means how many period? If it's just one period, means it's go to half, right? If it's two period, it means go to half of half, a half square. So how many period we have? The total time is 48 hours. over. Alright, that means it's so many. Yeah, what I get is P is 40. So what I get is 3.4.3 around 2 days. Oh, hello，
张老师，
哎，您讲。
你们下课了吧？我们还有2分钟就到了。
哦，没事儿，我们很快就下课啊。
啊，还没下课呢。
快了。
好的，好的。
对。
好的，拜拜。
好。Okay. Yeah, that's for part A. Part B. Part B is like A is 1, go to 1. Here is 40. Here is half. We suppose we need XR. Right? Divide 14.9 means how many periods? Then just go to find the X. Yeah. If so, we have 1 over 40. Base is 0.5. Then time, use this time 14.9. Let me see what we can get. 1 divide 40, get this. Take this. Time. Yeah, that's what I get. X equal to 79.3. So suppose it's an hour, right? Okay, let's go to check answer. Chapter 5. What's this problem? I forget. 27. Section 5.7, 27. Chapter 5 test. Oh yeah, 27. No. 21, 22, 27.
Isn't it like,
oh, where is 27?
Isn't it just up there? Because I saw 29 up by.
Oh yeah. Here, right? You say we match this. 79 hour. Okay, yeah, not for contents and formulas. When you do homework, if you are not sure, go back, spend more time and review.
Homework is
again, chapter test.
okay.
I'm not sure if you have finished all of them. If so, you can double check, or you go to find more problems in each section. Okay, yeah, homework is chapter 5 test. Okay.